everybody, and welcome to another episode of Connect Conversations. Today's conversations is about operating practices, as in brought to you as part of a MOBIUS Connect's ongoing YouTube series, Connect Conversations. I'm Kim Fugger, the manager of MOBIUS Connect, and I will be your moderator for today's session. First, I'd like to take a moment to introduce the hosts of Connect Conversations series, Global Reliability Improvement experts, Doug Plucknette and Ron Moore. Doug and Ron, are you both there with me?
I'm here.
And so am I.
Okay, fantastic. Well, before I pass the microphone over to you guys, I want to encourage our audience that is here today to submit any questions that you may have into the question panel of your GoToWebinar screen. And Ron and Doug are going to be more than happy today to answer all of your questions live throughout our time. Your questions will be answered on the air anonymously, so no need to worry about getting called out. Doug and Ron are here to provide their advice and perspectives from their experiences and are here to help you. All right, Doug and Ron, I'm going to go ahead and pass things over to you guys.
All righty. Thank you. Ron Moore here, Doug Plucknette, my cohort in crime today. What we're going to talk about today is operating practices, and in particular, we're going to review what I view as a better definition for reliability than you may have been exposed to, and we're going to look at, just touch on OEE. We covered that in the last session, so we won't go into any kind of detail. And then we're going to talk about the need for a production and maintenance partnership if you're going to have high performance, highly reliable operation. And we'll touch on process stability, how we get good process stability, shift handover. We'll cover a little bit on that, operator care, and so on. Each one of those topics we could probably spend an hour on. So this is just going to be like the highlights of all those practices. Doug, did you have anything to add to that?
I think you covered it pretty good, Ron. It's going to be a pretty quick discussion today in terms of rapid fire type stuff because we do have a lot to cover. So I'll let you get started and join in where it's applicable. That's for sure.
Okay. All right. Well, I mean, the first thing I want to do is, this whole series is about reliability, and I wanted to offer people a little different definition of reliability than what you might read in SMRP or SAE. Those are focused on, I think, primarily equipment and its ability to perform a given function under stated conditions for a given period of time. What I'd like you to think about, if you're in a production process, is think about reliability as the ability of the production system, the process, to produce maximum amount of product, 100% quality, on time, in full, at the lowest sustainable cost. Now, that's a little different because and I'm not suggesting, by the way, that you should actually produce all that you can. No, you gotta make to market, make to demand, but you ought to be able to achieve maximum demand in some sustainable way, according to the capability of that production process. So let's say it one more time. It's the ability of a production process to produce the maximum amount of product at 100% quality, on time, in full, at the lowest sustainable cost. Now, when you can do that and you have the capability to do that, then you have a really reliable operation. And OEE, overall equipment effectiveness, or in some cases, different people call it by different names, asset utilization, is the best measure of a given production operation's reliability. And if you want more details, you can go back to that other webinar, and we discussed that in some detail. So why am I, encouraging you to take this approach? Well, what I've found is in a production operation, something on the order of 70% of the production losses, your inability to produce, has nothing to do with the equipment. So if all you're focused on is the equipment, then you're missing a huge opportunity. So measuring and managing all those losses using some form of an OEE measure is really critical to your success. So if it's not equipment related, what is it? Well, it's things like, depending on the operation, transition losses, product changeovers, quality losses, short stops, no demand time. It's in, production schedule changes. Make this, not that, but you're already set up for that. It's that sort of thing. The other thing I've found is that in a typical production operation, about 2/3 of that 1/3 that's left is not because of poor maintenance. It's because of other issues around, for example, poor operating practices, startup, shutdown, operating practices themselves, or poor design. Maybe it's hard to operate or hard to maintain. So typically, maintenance only controls about 10% of the total production losses in any given operation. So I think it's really critical to take a holistic view of reliability as being the ability of the plant to produce quality product at a maximum rate, on time, in full, and so on. And of course, at the lowest sustainable cost. I'll pause there. Doug, anything to add to that?
Yeah, what you're saying jives with the measures that I had when I was working at Kodak in our photo chem division. We had OEEs that were struggling, low to mid 60s on a lot of the machines. Some of our best machines were low 70s. And but as we first started measuring this and reporting it out to our operations manager, she was a little shocked at how low they were, but then even more shocked when I told her, the largest percentage of our losses have nothing to do with maintenance. It really has to do with our incoming materials, right? Quality of the caps we were putting on bottles, and the reliability of getting those things, right? They were trying to do JIT at the same time, and coming up short when they'd have an issue on the machine. So it's really one of those things that we need to focus on what our losses are, but that's not our process today. Let's get into the operating stuff that we.
Yeah, well, I will add one additional comment to what you just said. A lot of companies say, well, we're trying to apply lean manufacturing. Well, if you're not reliable, you can't
You
be
got no
lean.
business with lean.
Yeah, you're not ready. The foundation of lean manufacturing is a stable process, which means you got to have good reliability, good predictability, all that sort of thing. So, anyways, that just for all y'all out there that want to do lean, and when you're not reliable, you've probably been smoking something you ought not smoke. So I want to quote a guy, Charlie Bailey. He's a retired VP of Eastman Chemicals. He said something once that really stuck with me. He said, reliability cannot be driven by the maintenance organization. It must be driven by the operating units and led from the top. Now he had a basis for saying that, because he tried to get really good reliability by putting in place predictive maintenance and PMs and planning and scheduling and so on, and he got a little bit of improvement. It wasn't for naught, but he didn't really get the substantial improvement until he actually went to the operating units and said, I'm going to hold you responsible for reliability. And reliability is going to be a more holistic approach. That's when he got just, a major change. Another way of thinking about that is, to expect maintenance to own reliability of a given operation is like expecting the mechanic at the garage to own the reliability of your car. They can't. They can help. They can fix things. They can give you some guidance. They can make sure, work with you to do your PMs, but they can't make your car reliable. If it's not designed well, and if you don't operate it right and look after it, it will not be particularly reliable. Doug, you have anything to add to that?
But in regard to operating practices, what are the things that we should be focusing on today, right? In terms of if I'm a manufacturing manager, what are some of the things, those practices that make a change, that make that difference that you're talking about that this VP went into?
Yeah, well, probably the biggest one is to have, at a high level, we're going to get into some of the details here in just a bit, but at a high level, it would have to do with having a good production and maintenance partnership. One where they sit down, put their heads together and say to each other, what do I need to do for you? Well, here's what I need you to do for me. Both parties have that discussion and they come to an agreement about how they're going to help each other achieve high reliability. And they might put some measures in place, and they might, do a monthly review of those measures and those, issues that arise, because they'll always arise. And then on top of that, I think that there ought to be some common measures that they share. And my favorite ones are production schedule compliance, maintenance schedule compliance, and maintenance and repair costs. I think those ought to be shared by production and maintenance, so that if a production guy wants to, make product when maintenance is scheduled, he's going to suffer on his performance review because the maintenance schedule wasn't met, and vice versa. Maintenance guy wants to do maintenance and production's not met, he's going to suffer on his performance review, and they both suffer when the maintenance costs go too high. See, my experience has been that most of the defects that create these problems are not controlled by maintenance. So you start with a good production and maintenance partnership agreement, and you use that as a basis for continued communication to eliminate the defects and manage the losses in your production process. And if you have that, you're a step ahead of most folks. So any comments on that, Doug?
No, I think that I shouldn't say no because I am going to comment. There'd probably be a third party that I would pull into that to that team, and that would be purchasing, right? In terms of our maintenance inventory, so our spare parts inventory, plus our in-process inventory for operations. The stuff that they buy to make whatever we're making, right? Those folks need to be a part of that circle because they have a huge impact on reliability.
Yeah, and longer term, down the road, strategically speaking, the capital projects guys need to be in on it.
Absolutely.
Because they need to understand where the difficulties are arising because of the design of the system that makes it less than ideal to operate and maintain. One other comment, I'm glad you brought up that purchasing, and the production losses related to purchasing. Those can be significant. Just a little example, was working with a coal-fired power station once, and the purchasing guy had found cheap coal. It was really cheap coal, but it was also really hard to process, had a low heat value, came with all kinds of rock and debris and detritus, which, tore up the ball mills and, created all kinds of problems with the fuel efficiency and so on, but it was cheap. So, and likewise for spare parts, you want to minimize your working capital, but by the same token, which would be spare parts as a chunk of that, but by the same token, you got to minimize the risk to the maintenance guys and having the stuff they need to get you back online when you have a problem. So those measures should also be shared, the level of working capital and the stock out rate. But anyways, that's enough on that for the time being. So maybe the next thing we ought to talk about, I want to talk a little bit about process stability and how one technique for achieving that. And that's this: for a given process, you might have 3 or 4 or 5 key process variables. Okay. And someone somewhere in one of the groups would have established upper and lower control limits for those processes. So if you want to get better stability, what you ought to do is use those control limits. And anytime you go outside those control limits, you tag that with a cause and you make some measure of the time and duration, the magnitude and duration of the excursion outside the control limits. And you might look at things like not following SOPs, raw material, instrument problems, equipment reliability. So you have some categories, 4 or 5 categories that you use to segregate those excursions. Then you put them into a Pareto chart, and then you begin to manage them. What caused that? Oh, that was an equipment problem. Okay, what was the context of that? How much impact? How about raw material and so on? And so you begin to manage those excursions. And after a month or two, what you're probably going to see is much tighter control limits on your process. And as such, you're probably going to get better stability, better performance, and for that matter, better equipment reliability. So that's one area that I think needs more attention in most operations. Doug, do you have anything to add to that?
It's interesting you bring that up because I just last month worked with a customer. It was one of my first travels in quite a while. They were having an operations issue, a pretty unique one. And when I went down and observed the lines and watched them run, and then saw that they had live OEE up on the board in this area, and it was quite high. It was it was in the mid 90s. And I said, I'm pretty impressed. Is that typical? Or is this just a great day that we're having? Like, oh no, that's I could show you that. And he said, in fact, what we've done is because we got so sick of seeing the same numbers up there, is we set control limits on it now, and that's how we've even tightened our process up. Is when we go up above, or so we have a great day, we want to know what the cause was for that, right?
Yeah.
And when we have an off shift or a bad one, we want to know what the cause was for that. And in doing that, we bumped that number up. We were in the low 90s, and we didn't think we'd ever make the mid 90s, right?
Wow.
But that's how we ended up finding those defects that were causing us problems and got us a little extra more out of it. So
yeah. Let's see. We got a question here. The question is, would you say the plant production manager and the operations need to communicate better? I comply and fill out apparently the maintenance sheet weekly, and often wonder what they do with them. The short answer is yes. I mean, what do you do with them? One of a boss I had some time ago, he said, well, I was complaining about having to report too much stuff, and he said, well, stop doing it. And I said, really? He said, yeah. And if they really need it, they'll let you know. So, and I'm not suggesting that in this case, but yeah, there does need to be better communication. And remember, I've said earlier that production and maintenance partnership, that partnership would set the standards, the expectations around what that communication is, why you need that, why that's important on both sides of the production process. So yeah, the short answer is yes.
Well, I always like to relate to sports when I can. It's like the NASCAR thing, right? It's like the driver and the owner not talking to the folks that put that vehicle together and maintain it in the pit crew, right? Let's just ignore those people, right? If they have input on a weekly basis, on a race by race basis, and that's how they improve time and time again, right?
Yeah.
Is by listening to that. And that takes communication. It takes a formal meeting to sit down and say, all right, here's the things that we're seeing. Here's some of the issues we're having. How are we going to deal with it?
Yeah. Well, I relate more to basketball. And, if you got a crappy point guard, you're never going to win. So it's like having a lousy quarterback, So, but yeah, each team member plays a role, and there has to be really good communication amongst those folks, So let's see. Let me back up to the top. No, okay, that was the only question we got so far. You feel
Okay.
free to tack on an add-on question if you like out there, if we haven't answered it sufficiently. Anyways, next point I'd like to make is related to process stability, and that's this: every shift should run the process exactly the same way, following the same set points, following the same startup and shutdown procedures, using checklists. You know, process stability comes about when you aid in that process when you do that. I've been in too many operations, second shift comes on and they go, and then the third shift goes, and then the fourth shift goes, and then the first shift comes back in and puts it back right. Well, every time you tweak it unnecessarily, that is, you're within your control limits on your key process variables, and you tweak it to try to optimize it, you're creating what amounts to an excursion. And then the other guy comes in and creates another one. Before you know it, you've lost stability. I know one operation where they set all the shift supers down and said, first shift, for the next week, you're going to run it like second shift likes to. Second shift, next week, you're going to run it like first shift, and so on. And they just took each shift's input, set up some standards, and every week, every shift had to follow that standard. And the funny thing was, they got better performance every single week. In fact, it was better than it had been in the previous 6 months, not because any one shift was better or worse, but because they were consistent in how they operated the process. And so getting that process stability across shifts is really, I think, really important. Doug, you want to add to that?
I do know that those noises you made, those will be in the highlight reel.
Whatever.
Yes. In terms of operating consistently, I agree with you with the checklist 100%. Here's the thing: the people like to believe that their experience means everything, right? And I tell them your experience means everything only to you, right? But it means a lot more if you share it with others, right? And by sharing it with others, we can develop better procedures, better startups, better shutdowns, better product changes. We've done some great things with customers in the past of making fixtures for product changes, right? Which makes that change consistent time and time and time again. So when we run product A, product B, product C, it's consistent time and time again, right?
Yeah.
Your input and the input of the people that run that equipment is the only way that gets done efficiently in a way that delivers the best.
Yeah. We got another question, Doug. It says, human error will happen. So what kinds of tips would you add in creating effective SOPs? Well, for starters, I would have SOPs, and I would train people in what those SOPs are. And then I would do a periodic review of all the SOPs, getting people's feedback on whether or not they're accurate, inaccurate, or not. SOPs, I like to think of those as checklists. You got to make sure you do this in this sequence at this level and so on. And, it's just kind of a tedious process. It's something you ought to do, that you have to do. And a lot of folks don't. I've been in operations where I've said, okay, I want you to show me how you start up this, I think it was a mixer or something. And I had the procedure, the SOP, right with me, the startup procedure. He said, well, we do this and then we do that. And I said, whoa, wait a minute. That's not in here. He said, oh, yeah, everybody knows that, except that new guy who came on at midnight. And I said, okay, go ahead. And he said, yeah, next thing we do. And I said, wait. That's not what this says. This says this. And he says, oh, yeah. Well, we changed that a couple of weeks ago. Okay, let's continue, And the point being, the procedures were there, but two things happened. One, he wasn't really following the procedure because he sort of had it done in his head. But the second thing is the other folks working with him on different shifts, a lot of them were not trained in the SOPs. So having, rigorous procedures and reviewing them periodically and getting feedback from the operators, I think is a very high priority. And then having people adequately trained and disciplined to follow them, is also up there. So all these things makes for kind of a complex situation, but it just takes day-to-day tenacity to deal with it. Doug, you had anything to add to that?
Yeah, if I could add that, I think the line of business that I've worked with through the years, and you may have experienced the same thing, that does this business best has really been the chemical business. They're pretty tight on the way they have to operate, right? So therefore, they have a good management of change process. They typically have very good SOPs, and they also have a process that says, okay, I'm going to train this person, I'm going to certify this person, and I'm going to audit them from time to time, right? Yeah. And they also, some of the ones that are more progressive, set up reinforcement programs for the operators to say, look, read through these things and help us make them better each time, right? And so they give out, some type of bonus for those changes that come about, for people that want to become engaged in that process to help make things better. Because there are certainly times that the SOP can be overwhelming, right? And it needs to be improved by streamlining it. There's sometimes that it's too vague and it needs to be more detailed, right? So, but you need to include those operators to say, what's the best way? What works for all of us?
Yeah. Well, the other thing I wanted to add too was, human error will occur. In fact, there's a guy, I think he worked for Bosch or one of those outfits, and he said CPK, that's a measure of process control of people, is such that you do things spot on about 90% of the time. Now think about that. 10% of the time you're going to screw it up. And now take those same people. You're in an organization where you have maybe 300 or 400 or 500 people. Each one has a CPK of 90, such that it's about 90% spot on. And now you interlink all those people. Guess what you get? A lot of opportunity for screw ups. So, and the point being, don't use human error or when you find errors as a club to beat people up. Use it as an opportunity to go back and find out why, what we need to do differently, how much more training, what additions to the procedures, and set expectations and standards around that. Otherwise, people are going to hide stuff. If they think they're going to be beaten over the head with a club, they'll try to avoid that, and they will hide from you and hide whatever may have happened. So that's just one other comment. I want to turn next to, you want to add to that, Doug?
I saw one of those hidden things caused us to run bad product on a machine for an entire week while we brainstormed it trying to figure out what the heck went wrong. And all it was if somebody had stepped up and said, hey, I messed up and I dropped this into a tank, right? And instead it was, right?
Well, it would have to be, in my world, at least when I used to actually do some of this stuff, it would have to be pretty egregious before I would, go get all over somebody,
Right.
Really, most people out there want to do a good job. Yeah. You got to make sure they can. So, all right. Let's see. Next topic I wanted to talk about was shift handover. It's more than a wave in the parking lot. Okay. It requires, face-to-face contact. There ought to be a checklist, if you will, of what you're going to cover. I've seen some organizations where they literally have a little block diagram of the production process with variables and measures and so on it, where they go through that and they tell the next shift what's happening relative to that and whether or not there were excursions or whatever may have happened. And the next shift coming on has to, of course, be attentive to that and ask questions. And usually that takes maybe, 10 or 15 minutes. The other thing about shift handover, it's really important when you have a big experience difference between shifts. You got a bunch of greenhorns coming in, a bunch of veterans leaving. It's really important that you educate, train, make those folks on the next shift capable. It's also really important after a major maintenance effort, because your highest risk of failure and defects is right after or during startup, particularly after a major maintenance effort. And another time is after, say, a long absence of key personnel. Somebody's been gone, a key player has been gone for a month, and they're just coming back, and things have changed, and they may not be aware of that. And then finally, maybe after a significant transient event, particularly when you have long delay times in the process, there needs to be a really good handover so the guy coming on doesn't make corrections that have already been made that take a while to stabilize. And in fact, if any one of these happens, you're more likely to have a major incident occur when you don't address some of these issues. So, Doug, you wanna add to that?
Shift changes is one of those things that if you don't provide people with the format, and again, we get into procedures, and I tell people, you don't really need a procedure for shift change. You need to have a discussion about what should be covered, right? And if that evolves into a procedure, I guess so, right? It reminds me of my very first customer was Whirlpool, and they were not measuring OEE at the time. In fact, I shouldn't say that. They measured OEE by the plant as opposed by product line, right? And so I convinced them, start measuring OEE on your critical assets and make it visible, right? And in fact, the lead operator should be the person that's putting that number together shift by shift, right? And their plant manager said a couple of weeks later after we got it going, wow, what a change. I walk in the morning and he says, I see the operator standing there pointing at that board and talking about all the stuff that's on there. Well, holy smokes, we've been running at 82, 83, and I come in this morning and I see your number 56. What happened last night? Right? And they talk about what the losses were, what the problems were, where they have the line, whether or not it got fixed, what they can expect coming in, right? So they've got good information to discuss about handing that process or that machine over, right? When you give people the information like that and put that into their hands, they have something to discuss, right? If they're not responsible for any of those numbers or any of that output, what will they discuss besides that? Hey, who won the ball game last night, right? Well, how's your bowling team doing?
Yeah.
You ought to see what my wife made me for lunch.
Yeah, or my kid won whatever, the first place in the marathon or some such thing, whatever,
Exactly.
So,
and it's great to talk about those things as well, but we really ought to be talking about what's going on with our equipment, what's going on with the process, and how we do it in terms of our goals day to day, week to week, month to month.
Yeah. Oh, by the way, Doug, I just wanted to affirm my experience relative to chemical plants, refineries, and so on. They do seem to do a better job, with their SOPs and SOCs and all that sort of thing, because they know the consequence of failure can be really severe, including license to operate, explosions, deaths, and so on. So they do tend to be quite a bit better because most folks in the operation understand the consequence of failure can be really serious. So, and speaking of, people caring, let's talk about operator care, operator ownership for just a bit. Some people call it operator-driven reliability. My view is that operators are at the heart of process and equipment reliability. They should be knowledge workers, that is, have fairly intense training and development. They should have empathy for the product and the equipment. that is treat it like it's their own. You know, my mother, I'll quote her. She said, "Take care of the place where you make your living, so it will take care of you." I mean, that's a real simple rule that I've always tried to adhere to, and that I think would do everybody in the world really well. Take care of the place where you make your living, so it'll take care of you. I've really never understood people who go in with a, give a crap attitude. No, that job and that equipment, those processes are paying for your car, your house, they're feeding your family, they're allowing you to, go on vacation. Why wouldn't you take care of it? So it's kind of a mystery to me when I see folks behaving like that. And I do think most folks want to do a good job, but management has to create the environment where they can. Management has to create the environment where they want to care about the job, the equipment, and so on. So enough philosophizing. Doug, before I go to some, nitty gritty, you want to comment on that?
In terms of operator care, there are several different products and processes out there that folks use, TPM being one, RCM being another. It really comes down to what are the things that need to be done day to day, shift to shift, that are convenient for the operator and help make the process more efficient, more reliable.
Right.
So
yep.
I know that in the past when I've done RCMs, we get to a point sometimes where you can see the operator's a little bit worried that there's so many tasks coming over, right? And I'll give them the old timeout and go, hey, look, when we talk about these things, I realize there's 4 maintenance guys in the room and 1 operator, right? And they'd love to give you as much as you can handle. It's up for you to say what's realistic, right? Not just for you, but the other folks that run that machine. You're one person, right? So you're the representative. What's realistic in terms of things that you should do to make this process work steady, as you say, reliable, day in, day out?
Yeah. Well, one of the techniques I've seen used to do that, in fact, one of the techniques I've used to do that is you pull together, a couple of operators, shift supervisor, a senior operator, a maintenance technician, a maintenance supervisor, maybe an engineer. You put them in a room and you ask the questions you just alluded to. What makes sense for you to do that would make your life better, give you a more stable process that would help assure the reliability of the process and the equipment? What makes sense given all the other tasks you have to do? What makes sense? And just facilitate a discussion about what makes sense for them to do that actually adds value to the business, that makes both lives easier. And you grind through that. And you look at things like, well, the basic stuff, look, listen, feel, smell, process, condition, but you also look at other things like maybe check, tighten belts. Now, you may or may not want to do that. I'm not saying you should or you have to. Like lubrication. I don't like operators doing lubes in refineries and chemical plants because there's just too much complexity there. But if it's a machine tool and you got 2 lube points and 1 lube, hey, that's easy. They ought to be doing that.
Right.
So you just grind through it, maybe cleaning, housekeeping, simple calibrations, maybe packing, filters, that sort of thing. But you grind through all that, you make a list, you pass that through the other shifts, get their feedback and their input, because some shifts may not be able to do that for other reasons. Anyways, you get feedback, you finalize all that, then you train people. Then you follow up with the supervisor, making sure that stuff gets done. And you go loop back around and review it a month later to see, well, did that work or not? What do we need to modify? Now, that's time consuming, but not doing it will be more time consuming because you'll have more issues and problems crop up. Doug, you Want to add to that?
I can tell you that one chemical plant that I worked with, one of their major struggles was, when they went to the PLC and the DCS to operate their process, and they no longer had to go out and open and close valves or take samples by hand because all that stuff was automated, right? They struggled with stuff just out and out failing that the operator didn't hear, didn't see, didn't feel, didn't smell because they weren't doing rounds anymore.
Yeah.
Right. So they had to come up with a way to say, how do we get the guys out to do rounds? What should we do? Right. And they tried a number of different things, and they finally talked to one operator and said, put gauges back in. And they said, what? Yeah, put some pressure and temperature and flow gauges back in and give them something to look at when they're out there. Right. You tell them to record the pressure on that gauge out there and bring it back in and compare it to what the screen says. Right.
Yeah.
And they look at him kind of confused. He says, you can't just walk by it, right? You won't pick up on it if you're just walking by it. But if you got to stop for a few seconds to do something, you'll hear it, you'll smell it, you'll see it, right? Because you're spending time with it, right?
Yep.
Now that's altogether different from a widget line and what operator care means there. But business unit or business sector to business sector, this changes, and that's what's important to recognize. It still comes down to communication with the operators, doesn't it?
Yeah, it does.
What makes your life better?
Yeah. One of the things that often comes up is operators should do inspections, and of course they do. They do lots of them. But if you're going to incorporate this vis-a-vis a TPM review or an RCM analysis, you have to make some decisions, I think, in there about, well, who's going to do the inspection? What are they going to inspect? What are the objective standards that tell them if a defect is present or absent? What do they do if they find a defect? They fix it themselves, they pass it along to maintenance, they ignore it, so there has to be some analysis as to that inspection process. It's not just go out and inspect. Who does it? What do they look for? What's the objective standard for it? What happens if they find something that's not quite right, and that sort of thing. And those all have to be incorporated into the thinking for folks out there.
Absolutely.
So that's anything to add to that?
No, I'm good with that.
Okay. All right. Now this is, I copied this from a guy named Doug Plucknette. You might know him.
I do.
He says he's got 10 tasks for operators to assure reliability. Do you remember what those were? All 10?
All 10 tasks to ensure operator reliability.
Yeah. You wrote this. I'm just echoing what you wrote. You want me to read it to people?
Go right ahead.
Okay. This is from Doug. So number 1, keep it clean.
Yep.
Amen to that, It reduces wear and assures pride and ownership. Yea, verily. Follow the checklist and update it as you learn, and make sure everybody else is informed about the updates. Do precision product changeovers. That is, standardize each one. I was at a dog food plant one time, and their changeover process was a total disaster. They just ran it and ran it and ran it until it finally ran. And that usually took half a shift or a shift. And you're going, wait a minute, guys, there's got to be one best way. Figure it out and put it in place.
Yep.
Next one, learn and apply statistical process control principles. Now, we're not looking for folks to be, statisticians. We're just looking for folks to look at the upper and lower control limit and figure out what's causing it to go through an excursion, and then work on that. It's not you're not going to be doing, normal and, binary distributions and T distributions and all that happy stuff. Anyways, next one is learn and apply root cause analysis and troubleshooting techniques. Troubleshooting techniques probably going to take some training. Root cause analysis starts with 5 whys.
Yep.
Why did that happen? Where's your evidence? Why did that happen? Where is your evidence? You know? And I'm a big fan of 5 whys. Learn and apply TPM and RCM methods. You know? What's a functional requirement? What's the failure mode? What's the consequence? What are you going to do about that? I mean, it's when you just say it out loud, it's pretty simple. And you don't have to read Mowbray's book, or you don't even have to read Doug's book. You know, it's a good book. And you can throw in there, Doug, let me pause there.
I encourage you to read it.
Okay. All right. I've read it. I've read your book, you know. So anyways, and by the way, I thought it was one of the more practical books I'd read in terms of applying in a plant on operation. So for folks out there, I liked Doug's book as a practical tool. You know, Mowbray's book is, you know, it's really good technically, and, you know, but maybe not as good relative to actual day-to-day application. And there's some other books out there. Anyways,
My book will
next one.
certainly teach you how to do RCM if you follow it. It's pretty simple.
All right. Next one, apply data-driven decision making. And then I've got in parentheses here, RCA, RCM, TPM required data. You know, and if you want to guess, go get some data to back up your guess. Minimize job switching. Competence takes time. You know, a lot of folks out there, they'll, in the interest of exposing their operators to different operations and making it less boring to them, they'll shuffle them a lot. Well, when you shuffle, you're running the risk of instability. So if you're going to shuffle, you got to make sure that the guy you're shuffling into and out of have a similar set of skills or abilities, or you provide the procedure, standards, and training to upskill them so that that happens as smoothly as possible. I'm fine with shifting, okay? You know, moving people around to give them exposure. That's a good thing, but it has to be done with a degree of care and precision and training and so on before it can be effective. You know, Doug?
The sports analogy applies fantastically to this one. I'll even use basketball, your favorite. You wouldn't want that point guard to be your center, right? You wouldn't want your center to be your point guard. And going back to the NASCAR, you don't think that they have that guy that changes tires do the gas the next week, right? They become very specialized at what they do. And that's not to say that you shouldn't train a backup or have somebody there that knows how to do that job in case that person's out, right? It's like you said, there has to be a reason for doing it, right? And boredom can certainly be one of them, right? Somebody says, hey, I've been doing this 5 years and I'm bored. I'd like to look at something else. Okay, we'll start a transition. But I'm not going to play musical chairs. It does not work. It never has, and it never will.
Yeah. Well, at a higher level, I worked with a company that every 2 years they like to take their up and coming stars and move them to a new role. And that was long story short, that was a disaster. Because just about the time they became competent, you'd move them. And then they'd take 2 more years to get competent, and then you'd move them. Now, and you think about, for example, at a site, you got, let's say, site manager, production, maintenance, and engineering manager, or just pick 3 or 4 titles. And every 2 years, one of those guys is changing. What do you think that might create within the organization and the expectations and the culture and the standards and a whole bunch of things? Well,
yep.
Chaos. And after a while, the guys on the floor say, just another pretty face passing through. We don't have to pay any attention to them. You know, they'll pretend to pay attention, but not really.
I'm going to continue to do it my way because I know that he or she is going to be gone a couple of years from now.
Yeah. Anyways, the next one is train. Sorry?
What was the next one?
Well, the next one is train and learn all of these constantly. Yeah. Continuous improvement isn't something you do once and it's done. And changing an organization's culture isn't something you do once and it's done. It's something you continuously work on to try to improve. It's entropy is one of my go-to concepts. Systems deteriorate naturally, so you better be putting a lot of energy into keeping them stable. And then the last bullet point is be safe. Doing this will make you safer. And I've got a bunch of data that says a reliable plant is a safer plant, is a more cost-effective plant. I've got a lot of data that says that. So, and last thing I want to touch on, I've got some data here from University of Tennessee. I work with.
Can I add one more to my own list?
Yeah, sure. It's your list.
Communicate the goal often.
Yeah.
Right.
Yeah.
We don't do that enough, right? To tell people, here's where we are, here's where we want to go, here's what the goal is, right?
Yep. Okay. Got some data here from Klaus Blake over at UT. I worked with him from time to time, and it's just data on the level of operator care. And he's taken this from 200 different operations and taken the average in each quartile of the maintenance costs as a percent of equipment costs. And lo and behold, as the degree of operator care increases, the maintenance costs decrease. In fact, they're about half. When you have zero or essentially none of that, operators don't look after the equipment, take care of it. That's about 13% of equipment replacement value. And when they do that and do it in some disciplined, formal fashion, it's about 6%. So less than half. So again, I'll just quote my mother one more time. Take care of the place where you make your living, so it will take care of you. And I've got another webinar I've got to attend in about 5 minutes. So I'm gonna turn it back to you, Doug, or back to Kim, and then we'll sign off here. If anybody has any questions, feel free to contact Doug or me, and we'll do our best to answer them.
Well, thanks again, Ron. It's been good talking with you.
Yeah, likewise. Always a pleasure. So,
all right,
guys.
All right. Yes, thank you for another great conversation today. Is there anything else you want to add, or are we all done?
I'm all done because I got to go.
Well, enjoy, Ron. Thank you for your time today. Again, thank you also, Doug. I hope you guys have a great rest of your week. On behalf of the entire team here at MOBIUS Connect, we thank our wonderful audience for joining us today. All right. Have a good one. We'll see y'all in 2 weeks.
Bye.
Bye.
Okay, so this is the old guy in the old TV screen looking picture saying, you guys have a great day. Thanks for tuning in today. We appreciate you tuning in and listening to Ron. And again, any new questions, we're more than happy to answer them. Have a great day.